I did an earlier video on this portable digital IC tester, which is available through Amazon or directly from the, they claim to be the manufacturer in New Jersey, but I think they're just badging it. But anyway, did a review on it, commented on its strengths and weaknesses as I observed them, and I also noted that I had bought a much less expensive tester on eBay and was going to do a review on that as soon as I got it in. Well, this is that review. So switching over now, here's the eBay listing. LCD transistor tester, integrated circuit IC tester, meter, MOS, PNP, NPN detector. I don't know how many different places sell this, but I think there are quite a few. The product has no brand name on it, but it does typically go for, only area of 30 some odd dollars, so very economical compared to the Visitech tester that I reviewed previously, which goes for at least $225 and usually quite a bit more. So I'm going to do a review, comparison, demonstration of this and the Visitech units. So here are the two testers, the previously described and reviewed Visitech digital IC tester and the brandless IC tester, which tests more than ICs, so again the names are a little bit misleading on these things. The keyboard or the keypad on the Visitech is pretty robust feeling. It feels like you could use it for a long time without breaking it. And it's got a high quality 3M or at least 3M cloned ZIF socket. I presume it's really a 3M one. And then this one has more of a little bit cheaper feeling but probably adequate membrane keyboard or keypad. And a smaller, also labeled 3M, but it doesn't look much like the 3M logo, does it? I wonder if this is really their product. Not sure. Anyway, it's obviously a lot smaller than the Visitech. Probably about 2/3 the height from top to bottom. Slightly less than half the thickness, and again maybe 3/4 the width. Substantially less weight, although they're still pretty heavy. There's obviously some guts in here. The Visitech takes a single 9-volt battery, whereas this nameless one takes a double or a pair of AA cells. Neither one are rechargeable. The Visitech does have the ability to run off of a separate power supply. It needs to be a 5-volt regulated supply. Although if you plug it in while the battery's in, bad things will happen according to the manual. It also has a BNC connector for connecting up input signal, a TTL level logic signal, because the Visitech can also be a frequency counter. Whereas this nameless one here has no external connectors whatsoever. It's strictly whatever you connect through the ZIF socket. So I'm going to do a quick check here. First off, the Visitech is only for logic ICs. It does not claim to be able to handle analog ICs, optocouplers, LEDs, transistors, anything of the sort. And I've already demonstrated how that works, so I'm going in my other video, so I'm going to put that aside and concentrate on this new one here. So, by way of a manual, it comes with a single sheet of Xeroxed paper with so-called operating instructions, and then a chart on the back. So there are 7 keys: up, down, left, and right, an O key, a P key, and an enter key. The up and down keys are used to adjust the directory and change the model number of the IC being tested. and the left and right keys are used to move around within the menu and select the item you want to change within the menu. The enter key is used to switch the unit on and off, and it's also the testing command, or it commands it to perform a test on the designated IC. Nothing in the instructions, well, I shouldn't say nothing, but in the area where it describes the keys, it does not describe the O key, but otherwise in the instructions it does say if you push the O key, that's a fast shutdown, compared to going into a menu option and selecting shutdown and pushing the enter key, which is the other way. So I don't know why you wouldn't always use the O key. And P is the backlit key, which apparently doesn't have any function otherwise. So the unit is turned on by pushing and holding the enter key for a second or two. And I'm going to turn my overhead light off here. And it does have a glow to it. It's backlit, although not strongly backlit. If I push the P key, it performs a self-check. But according to the manual, it's supposed to turn the backlighting on. I'm not sure if just touching it briefly is supposed to do it or what. Let me try if I hold it. It just seems to do the self-check over and over and over again. So I'm not sure how that works. I'll turn the overhead light back on. So it says here, push the enter key for 2 seconds to turn it on. When the power is on, the system displays the current battery voltage automatically. Did it do that? Let's do it again. I'll turn the power on. I don't see it displaying any battery voltage. It says when the power is low, please replace the batteries, obviously, but apparently, let's see, low voltage will affect the reliability of test results and the machine will automatically shut down for protection. But as far as I can tell, there's no means to tell whether your battery's low or not. I don't see anything that would make it do a battery check. So let's see, maybe I should try pushing it and holding it for 2 seconds. Nope, nothing happened. So I'm not sure it has the battery check feature in reality. To switch it off, you can press the enter key in the off directory, or it will shut down immediately, or where it will shut down immediately, or press the enter button in any directory exceeding 10 seconds, then it will shut down. Or after 60 seconds without any operation, it will shut down automatically, or you can just push the O key. So there's a following chart here. It says the bottom of the chip should align. It doesn't say align with what, but the diagram here suggests it should be the top of the IC should always align up here. So typical. Transistors should be in 3 slots, which are on the bottom left. I'm guessing that means these, but it also said this was the bottom, so I'm kind of wondering. Opto-couplings should be optical coupling. Boy, look at this. Optical coupling pin on the IC socket, pin 13, when measuring saturable voltage drop. What? Zener diode drop between pins 13 and pins 14 of the IC. Note transistor shown corresponds to IC pin from left to right in the order of pin 10, pin 11, and pin 12. The order of pins shown by transistor corresponding to pin 10 pin, 11 pin, 12 pin of the IC from left to right. So could that be any more confusing? I wonder if they regard it this way in considering that this is the bottom. I don't know, it's pretty flaky instructions. Then on the other side they've got a directory of functions, and you should be able to select auto mode, 5 volt mode, and 3.3 volt mode. And if I go over here and push the right arrow, it highlights under the T of the word auto. That's as close as it comes to selecting auto. You think it would like reverse field or something, but it's just that one little underline character. And if I push enter, nothing happens. If I cursor over to that again and try pushing up and down, now I can get 3.3, 5 volt, auto. And that's supposed to refer to the auto voltage selection. It's supposed to be able to test 74HC series device, and it says same with 74LS, but it uses a different driver circuit. It does 74LS. Nothing is said about using regular 7400, and unfortunately I don't have any regular 7400, or actually any 7400 of any flavor, in my parts bins. All I do is 4000 and 4500 series ICs. It does say it'll do the CD4000 series. It'll do the HEF 4000 series, which are different from the CD40 series, although it uses the same driver circuit. Then it uses the HEF 40 series, different from CD40, same driver circuit. And then the 45145, which is the 4500 series logic ICs, and I guess there's a 145 as well. Never seen that. It's supposed to do a number of interface ICs, such as those made by Max, like the Max 232 and Max 485, which are like RS-232 adapter chips and RS-45 adapter chips. Certain chips in the 7500 series. It'll do op amps. It mentions only those starting with an LM, so certain very popular models. It doesn't give you any indication of how wide the span of the database is. It'll do transistors, but it only mentions, well, it says NMOS and PMOS, NPN, PNP, bipolar, and SCRs and 2D. I don't know what that is. It does, there's a dead bug that came on the manual. That's a free extra. It'll do Zener diodes, but it says only in the 0 to 5 volt range, so that's pretty limiting. Most Zeners that I would use would be higher voltage than that. It'll do certain optocouplers, but again, a pretty restricted set. It always says such as, and it gives some examples, but it doesn't say, you know, they would be nice if they had a chart or something. And it did power off here. I noticed that. I'll turn it back on. And other directories are selected from the automatic mode, apparently. So I go back here and select this. All that I can do here is select through these three choices if I use the up and down buttons. What happens if I use the left and right? I think it'll just move to the search. Yeah, it toggles between search and auto. If I push enter in the auto mode, it just says device not found. So how do you get this thing so it can select the other IC series? I should notice another thing I notice is it says seach instead of search. I'd like to think that's just because they didn't have enough characters, but there's room there. They could have put the word search in, so I think they just misspelled it. It's pretty flaky. Okay, here's the trick. Pushing the left and right buttons just toggles between seach or search and auto, and that's all you can do. But if I go back to the search mode, if I go to the auto mode first and try going up and down, all it does is selects 3 volt, 3.3 and 5 volts. Goes back to auto. But if I move the cursor under search and go down, this is where it allows me to select other menu options. So it allows me to select off. If I push the enter button there, it does turn off right away. Pushing enter turns it back on. It does the self-check. It passes the self-check. I cursor over under search and push the up cursor button. Now I can select 74HC, 74LS, CD40, HEF40, 45/145, light, which again would be for optocouplers. That says other, which could be the interface drivers, ZD, which is Zener diodes, TR, which is transistors, amps, which is op amps, and off. So let me push enter to get out of this. I'll turn it back on. There doesn't seem to be an escape button. There is some mention in the manual that if you push the enter button in certain modes, it'll exit, but all it does is it seems like it shuts it down. So I think the manual is not completely correct. So it's in auto, and I'm just going to randomly check some ICs here. I've got an LM339. I'll lift the ZIF socket lever, drop the IC in, lock it down, and push enter, and it pops up immediately and says LM339, which is correct. If I take the IC out and push enter, it says nothing found. I've lifted one pin of the 339 up and put it back in the socket and push enter. It still identifies as a 339, but it's not actually checking it. So in order to check it at this point, I need to somehow escape from this. Pushing the P button gave me an error, but I think that'll at least got me out of the mode I was in. So now I can cursor left under search and go up into the LM series or amp, and plug in 339. So now I cursor over and it goes right over. So it's assuming LM on everything. It doesn't even allow me to select that. So I got the 3, I go over 1, let's see. Oh, it's only allowing me to select certain ones. I can't change individual digits. So it does allow 339 to be selected. So now I push enter and it says the chip is okay. It says that with a pin lifted up. That's pretty suspicious. So now I've got 2 pins lifted up. I'll push enter again. Ah! Now it faults. So here's the LM339 pinout, and the first pin I lifted was pin 5, which is one of the inputs. There are no unused pins on here. First I thought maybe it passed it because it was an unused pin, but no. It was only when I lifted pin 3 that it didn't work, and pin 3 is one of the power supply pins, so it obviously needs that to work. So I'm kind of concerned about the reliability of the test on this part. So once again I've got the chip back in the socket. This time I've lifted pin 1, which is one of the outputs. I would certainly hope it wouldn't pass with this lifted, so, and it does say fault. So it detected it didn't get an output, but it did not detect a fault when I lifted an input pin. I would think that would have been necessary. So I'm thinking its algorithms are not all that thorough. So now I've got an LM324 chip in there. I'm going to select auto. I'm going to push enter, or actually I'm going to go back to search and push enter. And it does immediately come up with LM324 and also suggest an LM2902. but it's definitely a 324. And if I go back to, I push P to get out of there, it gives me an error. I go to search and select up. I go through it till I get to amp, and I select 324. It's already selected, it's the first choice. I push enter, and it says it's okay. I push P to get out of there, and I drop a 555 timer into the socket, and I push enter. It immediately comes up and identifies a 555. But I don't know how to test a 555 because it's not in one of the categories listed in the manual. So how do you actually make it do a test of that? Well, I'm going to guess that if it identified it, that maybe I should go to search, and it's not a 74 series or a 4000 series or a 45 series. It's not an optocoupler. Maybe it's other. What happens if I go over here and here's the max chips. Seems like we're repeating the same few chips, so it's not in other. It's not a Zener diode, it's not a transistor. Apparently there's no way to force it to test the 555 other than that it identifies it, so that's kind of disappointing. Now I put an LM387 in there, which I don't remember what it is. It sounds to me like it might be one of those low power amp chips. So I get it back to auto mode and I underline search and I push enter, and it doesn't know what that is, so it cannot identify that particular chip. And here's a LM833. Do a search and it identifies it as a TL082, which is kind of weird. What's a TL082? Okay, here's what the LM833 is supposed to be. It's a dual op amp in that pinout, and the TL82 that was identified by the tester. Here's the TL82 package. Pin 1 is output A, and then it's minus and plus on pins 2 and 3. And 4 is the minus power supply. 8 is the plus power supply. 7 is the second output, and then minus and plus. So the pinout is the same. I don't know if the parts are very close to each other, but functionally they seem to be pretty similar. So that's not a bad call on the tester's part, but considering it already knows all these LM parts, you think it would have identified it as an LM833 instead of as a TL part. I've got a logic IC here. This is a 4503, or actually a 14503, same difference I think. I drop that into the socket and do the self-test, and it immediately says it's a 74367 or a 4503. Now I had the same thing with the other tester, with the Visitech, where it identified the 4503 first as a 74367, and when I pulled up data sheets it said there was a subtle difference between them. But then some comments to my video on the Visitech said that I was mistaken and that the two parts were really the same, at least the 74 CMOS series 367. So I haven't gone through and looked exhaustively at all the different data sheets that can be downloaded for the two parts to see if maybe just the ones I was pulling up were printed in error. and maybe they really should be the same, but at least there's two different devices thinking these are the same part, so I'm going to give it the benefit of the doubt. Let's go ahead and test this guy here as a 4503. So I push P to get out of there, I go over to search, and I go to the 45 series, I go to the right, and here I think it lets me actually put in the number. So let's see, 03. So here it lets me select from a wider breadth of parts instead of just toggling through a few that it knows. So I would deduce from that that it can handle more or less the whole series. Otherwise I think it would force me to select from just the ones it knows. Of course it would be a big list, so maybe it would just be prohibitive to go through that list, hence the way they're doing it. Anyway, let's see what happens. It says it's an okay part. Let me do the same check I did on the Visitech, lifting one pin. Okay, with the one pin lifted now, let me repeat the test. And it says fault. Alright. Alright, now some other things. I want to test some... well, I've already tested some op amps. Let's try some transistors and see if I can figure this out. I've got some 2222s here. That's always a good general purpose transistor to test. And it says that transistors need to be pins 10, 11, and 12. Well, I don't know what they're basing that on, but I'm guessing they're counting from this side going this way. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the lower 3 here. So I've got the IC jammed in there. I'm going to lock it down. And I wonder if it's able to do an auto detect. Oops, I have to escape from that mode, back into auto search, do an enter. It doesn't know what it is. So let me escape from that. Cursor left to search. And get to, oops, I went too far. Transistor, and go to the right. Doesn't let me go to the right, so I guess I just have to push enter. And it says NPN EBC, and the instructions do say that it's basing that going left to right in this direction, emitter base collector. So it has correctly identified a 2N2222 as an NPN transistor, and it has correctly identified the pinout. What if I flip it around the other way? Do the test again. Now it flips it around collector base emitter, so that worked. I've got some optocouplers here. Just in my parts bin, I've got a MOC 3010. And it says optocoupling pin of the IC socket, pin 13. So pin 13 should be this guy here. I don't know what they mean. Let me try just dropping it in there and see if it can detect anything. Doesn't do that. What if I put it down at the bottom? It doesn't do it. So I'm guessing this is not one of the ones that it knows about. What do I have here? This is a was also a Mach 3011. Well, it's a 3010 and 3011 I've got. So I can't test the optocoupler mode. Don't have any of those in my supply bin. Here's a couple of more. different models. Doesn't like that one. Tried at the other end. Doesn't like that one. That was a Hewlett-Packard 6N137. And I can probably guess that it won't know the 138 either. So let's assume maybe it doesn't know how to do an auto find on those chips. Maybe I should just go left and search out light and go to the right. Yeah, it doesn't like it that way either. Let me try moving it down to the lower set of pins. Nope. There's no joy on that. So optocouplers are a mystery on this. I don't know much what it tests, and I don't know which pins it should be in. It's supposed to be able to test Zener diodes. Should be between pin 13 and 14. So here I've got a random Zener diode stuck in between 13 and 14, and it doesn't like it if I just do an auto find. So I'm going to go to search and find Zener diodes, and if I go to the right it doesn't let me select anything. I push enter and it says it's a 0.59 volt. What if I flip it around and try it the other way? Okay, so with the Zener flipped this way I get a 1.87 volt. And with it flipped the other way I get a 0.9 volt. So this mystery Zener is a 1N5221, which should be a 2.4 volt Zener. So I'm going to try it one more time. So it's 0.59 going one way, which is kind of a normal voltage drop for a diode. And if I flip it the other way, I get a 1.87, which is definitely considerably lower than 2.4 volts it should be. So I'm not sure that I trust that. Well, I don't have a lot of other Zeners laying around at the moment, so I'm going to take the Zener test with a grain of salt. I thought I would try plugging in an LED just to see what it did. So I've got an LED stuck in the Zener diode pins, and it's giving me a 1.62 Zener drop when it's forward biased. And it does light up. If I flip it around the other way, it says out of range. So that's interesting. I did find in my junk box another Zener diode. I think this is a 5.1 volt part, and it's giving me 0.59 volts one way and 5.49 volts the other way. So it's certainly seeing a difference in the Zener voltages, and this one's closer to what I expected from this part. So the Zener voltage test could be kind of useful. So I thought I would just do a few more part identifications, and I'm going to drop in a this is a 4511, and it tested that correctly, or identified it correctly. Here's a 4584, and it identifies it as a 74LS14 or a 4069 or a 106. It did not identify it as a 4584. So this is actually a 4069, and I'm sorry, it's a 4584, and the 4584 is a hex Schmidt trigger IC, and the 74LS14 is a same thing but in the 7400 series family, so that matches up. The 4069 is a standard inverting hex buffer, but it is not a Schmidt trigger type, so the 4069 is an incorrect matchup, whereas the 74LS14 is pretty close, functionally equivalent. And the 106, I have no idea what that is. I'm trying to figure out if there's some way to pan ahead on this thing. If I press enter, it just repeats it, so I don't know if it's scrolled some number off the edge or what, but it'd be nice if it would have actually identified the correct part number. And here's a 4075. Let's see what it comes up with. 4075, that's correct. Here's a 4081, and it does correctly identify it. Here's a 4044. It gets that one right. A 4049. Didn't like that one. Ah, but there's a pin rolled over. Maybe that caused it. Now with the pin straightened, let me try it again. And it comes up with a 4009 or a 4049. So that's better. And finally I'm going to check it with a 4050. So here's the 4050. And it doesn't like it. Here's another 4050. Doesn't like that one either. Try a third 4050. These are all different brands. Ah, this one it found. So, I wonder if the other ones might be faulty. They're all junk box parts. Let me select a 4050 here. So I go out of here, I scroll to the left, I go down, CD 4000 series, select up to 50, push enter, and it says it's okay. You try the ones that bombed before. It says it's okay, but it couldn't identify it out of the bin. Anyway, so it's a fairly inexpensive tester. It seems to have some functionality. It's called into question its reliability in detecting faults of certain kinds on both logic ICs and op amps. It seems to be kind of iffy on the Zener diodes, and certainly has a big voltage restriction on the Zener diodes. It can be used to do basic testing of an LED. One thing I didn't do is check it with a SCR. I'll try that real fast. So I'm doing a check to see if it can identify a triac. Didn't find it. Doesn't recognize the triac. And I don't have any SCRs, so unfortunately I can't test that out. But I think this is one I'll hang on to. I trust it less than the Visitech for testing digital ICs, but it still could be pretty handy to identify some parts, and it definitely goes outside of identifying just logic ICs into at least some common op-amp packages and some other components. I think the ability to test the transistors is useful, at least identify the pinouts. The ability to test optocouplers, it seems to have a pretty restricted range, might still be useful for that. So I would give it a go for the very low price it sells for.